All right, traveling through, finishing up some of the necessary skills, math skills specifically. Line and slope, you do need to be able to work with the equation of a line, and you do need to be able to graph a line. And you need to be able to determine the slope of the line. So this all comes back from grade 9 and 10. So just very quickly going through this, if we have an equation y equals mx plus b, we know that the m is the unit rate or slope. So unit rate or slope, and our b is our y-intercept or initial value. All right, so you need to be able to interpret or take that information out. As far as graphing goes, if we use an example here, y equals 2/3 x plus 1, and I create a grid here very quickly. X and y axes. I know that I start at plus 1, so this is where I would start. Slope again, if m equals 2/3, that's rise over run. So that's how far I would go up. So here's my first point, up 2, across 3. So there we are. So then we can draw a line through it, and that would give us our line of best fit. So there we go. Similarly, if I give you a line, then I need you to be able to tell me the slope of that line. We are going to use, we're going to be dealing with rates, linear rates, so it is important that you can tell me the slope. So you need to be able to tell me that slope is rise over run, so I can count the squares and determine rise over run. So if I pick my 2 points, okay, this is my rise. It's basically the y2 value minus y1, or the change in y. So it would be that distance there. And the run, which is right here, x2 minus x1, which is my delta x, or my change in my x value. All right, so you need to be able to tell me the slope of the line. So I know you've done it in both grade 9 and 10, so I'm not going to spend more time than that. If you're struggling with that or concerned with that, please talk to me. Review of trigonometry. A couple things I want you to be able to do here. And just let's get this started here. So first one is Pythagorean theorem. You need to be able to do Pythagorean theorem as if with your eyes closed, so to speak. So the Pythagorean theorem is a must or a requirement, and just reviewing that. Okay. Remember, you have your a, b, and c, and we've got that a squared plus b squared is equal to c squared. I also need you to be able to do your primary trig ratios, so SOHCAHTOA. Also extremely important, you know that the SO is sine theta equals opposite over hypotenuse. I need you to know that CA is cos theta equals adjacent over hypotenuse. And I need you to know that tan theta equals opposite over adjacent. So that is an absolute must as well. And a reminder, primary trig ratios for right angle triangles only. Triangles only. All right. And then what happens if we run into non-right triangles, which we will? We need to be able to solve triangles that are not right angle. So if I label this for myself, A, B, and C, this side would be small a, B, and C. We have two options at our disposal. We have the sine law. So you do need to know or remember how to use sine law. I know you do that in grade 10 math, first unit. So sine law, it's either, it doesn't matter to me which way you do it, sine A over A equals sine B over B, and it equals sine C over C. If the sine law is not the correct one to use, then you have to use your cosine law. So the cosine law, if you're looking for the side, it would be a squared equals b squared plus c squared minus 2bc cos of angle A. If you're looking for the angle, theta would equal a squared minus b squared minus c squared divided by negative 2bc. And that's cos inverse, so I apologize, need a little bit more room. Cos inverse of that. All right, and those find you your two angles. All right, so a couple of examples with that on the next slide. So the first triangle, you need to recognize that it's a right angle. I see so many people right angle triangles using sine law. Way too much work. You need to realize, hey, this is SOHCAHTOA. I have a right angle triangle, which means this is my hypotenuse. That's my opposite side. The last side has to be adjacent. So from SOHCAHTOA, what do I have? I have a hypotenuse. So that means it could be either sine or cos. what am I looking for? I'm looking for the angle. So the other side I know is adjacent. So cos or tan. It's got to be the cos function because I know both a and h. So cos theta equals a over h. Cos theta is what I'm looking for. A is 5, h is 12. So I have cos inverse of 5/12. So that means that my angle would be, so with my calculator, 5 divided by 12 in brackets, inverse cos, I've got a 65.4 degree angle. And there we go. On to the next one. It is a non-right triangle. So when I look at this, I know all three sides. That tells me that I have to use cosine law. So from the previous page, I know that it's the cos inverse of c squared minus a squared minus b squared all over negative 2ab. So plugging that information in, cos inverse of, oh, I think I messed that up a little bit, didn't I? It should be bc. Yeah. So just changing that up, make that into an a, and sorry about that, my fault, rushing. BC, so from the previous page. So again, this would be corner A. So that means I would have 11 squared minus 7 squared minus 4 squared divided by negative 2 times 7 times 4. So using my calculator to determine that. So I'll have 121 minus 49 minus 16 equals divided by, in brackets, negative 2 times 7 times 4, closing brackets, equals 1, and cos inverse, so inverse cos, and I have 0 degrees. So I end up having a closed triangle. Well, that wasn't the smartest thing I've done today, that's for sure. If you'll notice 7 and 4 right here and here, they actually add up to 11. So that means the angle would have to be 180 degrees. So let's fix this up somehow. The easiest way to do that, let's change that 11 to a 14. That should be minimal disruption on your page. I'm going to change one number in the question and in the answer here. So let's try that one more time. Kind of funny. Should have seen that. So 14 squared minus 49 minus 16 equals, divide that by bracket, negative 2 times 7 times 4 bracket equals, so negative 2.3333, and now it doesn't work at all because I can't take the inverse cos of that one. So invalid. Well, that made a mess of everything. So that being said, let's go back to the 11 change that back to 11, change that back to 11. You get the gist of it. It actually ends up being 180 degrees. And there we go. So we end up with a flat triangle. All right, not my most shining moment in terms of examples, but oh well, it's the process which is the important part here. Okay, determining the length of sides of the right angle triangles and non-right angle as well. All right, so again, the first one, we have a reference angle of 40 degrees. We have a right angle. So I know this is the hypotenuse, and I know this is going to be my opposite side. Last side has to be adjacent. So from SOHCAHTOA, what do I know? I want to know hypotenuse, so it's either going to be sine or tan. I have the opposite, so I have all the information, so I'm going to be using the sine function. So sine theta equals O over H. Sine of 40 degrees is equal to 7 over X. So we need to be able to solve this type of question. So again, if you think of it, the sine function's over 1. We can flip both sides. So 1 over sine 40 equals X over 7. And we can do either a partial cross multiply or a multiply by 7 on both sides, depending on how you were taught previous year. And that's what we get for the value of X. So using the calculator, we know that 7 divided by 40 sine is my answer. So I get 10.9 is the missing value. All right, so that is the length of the missing side. Together. And the last one here, I see that I have the correct information to use sine law. So I would have sine A over A, sine B over B, and sine C over C. Plugging in my information, sine 30 over A equals sine 20 over B, and 180 take away 50 is 130, so sine 130 divided by 10. So I have one fraction that contains all the information. Break this into two parts. So I end up with sine 30 over A equals sine 130 over 10. The other one will be sine 20 over B equals sine 130 over 10. Isolating for A here, so if I do the cross multiply, I get 10 sine 30 equals A sine 130. So that means that A is equal to 10 sine 30 over sine 130. And B, same thing, 10 sine 20 is equal to B sine 130. So B equals 10 sine 20 over sine 130. That's the hard part. I'll let you do the calculator work there. So we use the sine law, so we break it into our two equations. All right. So that takes us up to the end of the second segment here. We're going to go through our third video, and we will talk about some stuff that'll be a little bit newer or challenging for those that have been kind of skimming through the material here. All right.